Yeah. I think I was not audible. Okay, just let me share my screen. Okay, I think, shall we start? If everyone is there, then actually we can start, right? Shall we start? Anyone? Or are we waiting for someone? Okay, I think we should start. Okay, so good morning, everyone. Welcome to the class of Cyber Physical System. This is a part of your PG certification program, Smart Manufacturing, organized by the National Institute of Foundry and Forge Technology, Ranchi. And this is Dr. Amit Sata, your facilitator for the cyber physical system. So again, welcome you all, and we'll move towards the discussion related to the today's session. Before going into the discussion about the today's session, just let me remind, or let me just brushing up the memory what we have discussed into the previous session. So basically we discussed a few things about the cyber physical system. Actually we started with the definition of system, then physical system, and cyber physical system itself, and importance of cyber physical system. And from that actually we came to know that the cyber physical system is mainly uh, integral part of the industry 4th revolution. And then we discussed the different industrial revolutions, starting from the first industrial revolution, second, third, and fourth, and what are their basic outcomes, what are their expected outcomes. So first industrial revolutions expected outcome was to convert the raw material into product. The second industrial revolution expected outcome was to achieve the productivity. Third one is to achieve the productivity with the help of integration between hardware and software. And the fourth one, although the productivity is the prime concern, but now we are actually integrating the hardware and software through internet. And then we discussed the opportunities related to manufacturing in India. So we actually started to define about the physical system, available physical systems in India in the context of manufacturing. And then we discussed the opportunity related to cyber infrastructure, mainly say internet. As we are dealing into the industrial fourth revolution, the internet is playing a very vital role in development of the cyber physical system. So we have discussed about the opportunity or infrastructure available in the context of internet in India, right? And then we slightly or say formally introduce the cyber physical system. But again, actually, to remind one point over here, we are going to discuss the cyber physical system in the context of manufacturing. So my entire discussion will be actually, you can say, roaming around the manufacturing system. I'm not going to touch any cyber physical system for the chemical industries or like that. But we'll decide the approach. We'll decide the overall approach that how to proceed towards the development of cyber physical system. And today's discussion will be mainly based on that. Lot many people are talking about industrial internet of things and cyber physical system and internet of things and smart manufacturing and so on. So today we'll mainly highlight the two of the main kind of system, which is industrial Internet of Things, what is it all about, and what is cyber physical system. So in today's lecture, we'll discuss about the overview related to IIoT and cyber physical system. What is it all about? And then we'll go through the few videos of the cyber physical system, how the typical cyber physical systems are working. And then if time permits, we'll also discuss the Indian government initiatives in the context of cyber physical system in terms of various schemes and all these things. And then slowly by slowly we'll move towards the cyber physical system. So as we discussed into the end of the previous session, we will divide the entire curriculum into the 6 unit: introduction, then sensors, microcontrollers, Internet of Things, AR, VR, and cyber security. So as we discussed into the previous session also, we'll start with the introduction, and then we'll touch up the individual critical element to build up the cyber physical system that we will try to discuss. This first physical system, then sensors, then microcontrollers, then either it will be IIoT or IoT, and then how we are actually representing the our physical system in a cyber world. It may be with the help of AR, VR, or maybe with the help of smart device, dashboard, and so on. And above all, we'll also touch up some of the feature related to security in integrating all the equipment. What are the protocols need to be followed, and what are the systems that we need to take care while we are having a cyber security. So as we discussed, we are going to deal with so many terminology during these terms. So this is overall what we have discussed into the previous lecture, and now actually formally we are moving towards the discussion about today's session. So first we will get an overview what is industrial Internet of Things. So actually before proceeding towards the overview, what I am looking into it, or what I am trying to present, if anyone is knowing what is IIoT in your opinion, right? Although I have plotted one assignment onto the Moodle that you can see what is your view about the cyber physical system and what are the observations that you are going to have during visualization of the video that we will be having in this lecture. Right? So what is your opinion about, what is your perception about IIoT? So that will help me to understand where actually we all are standing in terms of understanding. Just let me share one example with you, what I used to follow. Say as a facilitator and as a audience, they need to be onto the one common platform, right? For example, if I will write down a word called IIoT, then there is a separate picture, there is a separate visualization comes in my mind. So okay, if this system is going to be having this kind of arrangement, then we can say it is a industrial Internet of Things. Similarly, there will be a one picture which is coming in your mind whenever we will close our eyes and speak that IIoT. It means something pop up in our mind. So I want to know what is it, right? And before actually delivering or before providing the overview from my point of view, I would like to know from your point of view, what is industrial Internet of Things as far as your perception is concerned. So anyone, if you would like to respond, then actually I'm stopping the sharing for a few seconds, a few things. Okay,
Sir,
anyone?
as per my concern, IIoT refers to the extension and use of Internet of Things in industry sector and its application. Basically, it is a machine-to-machine communication and big
Yeah.
data and machine learning
So sorry to actually say that. First, actually, please speak out your name, introduce, and then actually,
Okay.
if you can,
Sir,
yeah.
My name is Sunil Gupta.
Yeah,
According,
Sunilji, yes.
according to me, IIoT stands for Industrial Internet of Things.
Perfect.
This means the Internet of Things used in industry sector and its application, with a strong
Okay.
focus on machine-to-machine communication and big data and machine learning. IoT enables
Okay.
industry and enterprises to have a better efficiency and reliability in the operation.
Good. Good. So you are having a perception that if I will be able to connect one machine with another,
Yes, yes,
maybe
yes.
with the help of internet or maybe any other connectivity protocol, I can say that I'm using industrial internet.
And communication
Yeah.
between machine to machine.
Okay, so you are extending that, okay, communication from one machine to another. Okay, good point. So actually you are highlighting two things. First, machine should be interacted with each other. It means there will be a
Yes, yes, sir.
communication and there will be a connectivity. And overall objective is to achieve the productivity, efficiency, and so on, right? Good.
Yes.
So
Thank you,
again,
sir.
good point. Internet of Things. I always personally think in that when I want to know something that I used to disintegrate the word and then individual importance of that word I'm taking into the consider. So Internet of Things, it means it is comprised of three words: Internet of and things. So things, as we know that whatever the things or whatever the system surround to us can be considered as a thing. And if I'm going to connect them with the help of internet, it means the connectivity is there, right? It means any two things need to be connected with each other, whether it is a you can say smart device with the washing machine, smart device with the refrigerator, smart device with the air condition, whatever, right? So there are two systems which we are trying to connect, and how we are going to connect. Earlier, it was a wired connection, then it was a wireless connection. Again, into the wireless, there will be a Bluetooth, Zigbee, and so on. And now, but we are trying to connect into the what you can say wireless through internet, right? Or say Wi-Fi. Earlier, there was a physical connection in wired connection, so uh, the person who is driving the machine need to be nearby to that. Wire can be of 1 meter, 2 meter, or maybe of 10 meter, but it should be within that range. Same way then the wireless technology came in terms of Bluetooth and Zigbee and all. Then obviously there won't be a wired connection, but there will be a limited connectivity between the a limited distance in which you will be able to connect. And then the internet came. So machine to machine, the distance can be uh, as large as possible because we are connecting through internet, wireless protocols and all. Okay. Any other point of view? If I'm going to define the IIoT, what is your opinion? Sunil ji has already defined or discussed his perception. Anyone? It is better to discuss, right? Before actually, otherwise it will become a bombarding of my perception. So I would like to know your perception going into the before going to present my view on that, right? Anyone?
Hello, good morning, sir. Myself
Yeah.
Abhishek.
Yes, Abhishek.
So, so IoT is a network of intelligent devices that connect the system that to analyze or collect the data.
Good, good. So it means we are trying to connect any system with the help of internet, and you are mainly focusing onto the one keyword that is a networking, right? It means we are going to connect two different. And same was highlighted by the Sunilji also that we are trying to connect the two devices. So connectivity or networking is the key role, and then depends on to the individual's perception about the outcome, right? We may define our own system because all we present over here may be belonging to the different domain, right? Someone coming from say casting, someone coming from machining domain, someone may be coming from chemical manufacturing, anything, right? So maybe someone coming from design domain also, but outcome is a different scenario altogether, right? So just let me actually uh, go into the my point of view, right? Okay, so what actually we will try to define by IIoT. First, actually, we need to have a one system, right? Any system. System may be irrespective of the domain. It may be a mechanical system, it may be a chemical system, it may be electrical, it may be anything, electronic system, anything. So first, actually, as far as the IIoT is concerned, when I want to apply the IIoT into my day-to-day routines or maybe into my industry, first I need to identify the system. So system may be anything. It may be related to any domain. It may be aerospace. It may be defense. Anything. It may be maybe medical also, right? Or even a domestic application, agricultural. There are so many fields or so many domains in which we can highlight the system. Then into the next step, we will be having a typical physical system as a part of entire system. It means now we are going to focus on an individual physical system, because first actually we will try to connect the internet or what you can say internet to a particular one thing, and then entire system will be connected. So first we will select the any typical system. For example, I'm going to select the mechanical system, as I belong to the mechanical domain. Then I will pick up any one of the machine. Maybe it is a very legacy machine, lathe, milling, it may be CNC machine, it may be melting furnace, it may be heating furnace, it may be anything. So suppose I will pick out anything, or it may be initially I will try to find out the environmental condition where the physical systems are belonging, right? So then actually third step, my objective is to further study about the physical system in terms of say identification of parameters associated with a typical physical system, which is a part of one huge system. So again, suppose I will take a mechanical system in which suppose I will further disintegrate and go into the manufacturing. In manufacturing, I will go into the subtractive process, subtractive, and I will go into the say typical lathe machine, and then I will try to find out what are the parameters or what are the things that I can actually sense out of the machine. So I can say that there will be a one of the parameter called say feed. There may be depth of cut. There may be speed of the spindle, or sorry, revolution of the spindle. There may be anything. And suppose I will talk about the furnace. I can talk about the temperature if I am having any other system, like say flow related to the system, then I can discuss about the pressure, flow. Suppose I will select the turbine as my physical system, then the pressure and flow will be very important, right? So I'm going to identify the parameters associated with it. These are the my, you can say, still I'm dealing into the kind of hardware related things. Then I can have a sensors who are actually or who are able to acquire the information from this hardware. It means I'm going to put the sensor. I'm going to put the sensor which can acquire the information or a required information. So if I will have a say different types of sensors starting from the DHT11, DHT22, proximity sensors, thermocouples, pressure sensors, anything. So basically all these physical quantities are trying to be converted, trying to be transformed into the digital world. So if I will say this 1, 2, 3 are mainly related to the hardware. Now the transition happens over this point. Point number 4, where actually the physical hardware is transformed or starting to be transformed into the digital world, into the software part. So as we discussed into the earlier lecture also, Industry 4.0 is nothing but integration between hardware and software through internet. So in my opinion, this is all about hardware. Now the transformation happened from hardware to software. So 1, 2, 3, hardware. 4, it is a device, it is a thing which will actually take the physical value into the digital. So for example, there is a one temperature, maybe say 30 degrees centigrade. I'm going to put the sensor over here, which has been developed by the fundamentals of physics, which used to convert the temperature, which is coming into the physical measurement, and it transform into the electrical signal with the help of either voltage or a current. And then this voltage and current again has been transformed into the digital signal through microcontrollers. So here there will be a typical hardware. Then the actually transformation happen from hardware to the virtual world, or you can say digital world. In that, we are transforming the physical measurement into the electric or a electric current or a voltage, and then they are further converted into the analog into the digital. It means voltage and current will be further disintegrate into the binary signal of 1 0 1 0, like that, right? And that is actually taken care by the microcontrollers. So essentially, we also need to supply some power to the microcontroller to do all these things. So then we are having uh, at the research level or at the student level, we are having a few choice in terms of say microcontroller, in terms of Arduino, Raspberry Pi, Jetson Nano. There may be Intel and higher version of microcontrollers, right? So there are so many microcontrollers available. There are so many sensors are available, and we are dealing with so many parameters in day-to-day life. So if I'm going to give you the assignment related to define your own physical system, suppose I'm going to deal with the metal casting as a my domain, right, of interest, then I can define so many parameters associated with the metal casting. I'm going to list out all the parameters. Then actually I'm going to decide which type of sensors are going to be used for that. And then I will connect these sensors along with the peripheral requirement like conversion of analog to digital signal. Then there is a power supply. Then there is one circuit board. At the experimental level, we can have a breadboard. But at the higher level, we can have a, you can say, PCB and all. And if further more higher level, we may have a embedded system itself, right? So we are going to define we are going to select the different microcontrollers. So as I told you, 1, 2, 3 hardware, 4 transition happens, and 5th onwards actually typical software related stuff, right? So once I'm having a microcontroller, and then actually I'm going to stream the collected data or whatever the information into the microcontroller that I'm going to stream to the server, which is located at my own place. It means I may have a client based server, or I am going to stream the data to the third party server, like say cloud based server. So I'm going to stream it. And then actually how we are transferring this information. As I told you, up to this, it is located at your place, at your machine. Now you are handing over the data to the server with the help of internet or any other mechanism, whatever you would like to have, right? Either you are going to utilize the Wi-Fi, LAN network, and so on. And for that, actually, we need to have a certain protocols. As I told you, the machines are connected with the microcontroller, so all are integral part of the machine. So there won't be any issue related to security. But here from the point number 5 to point number 6, while we are actually transforming the information, because now your machine is open to world from point number 5 to 6, while you are transforming the data from microcontroller to the server, now your machine actually will become open to the world. So for that, actually, you need to follow the certain protocols. Protocols in terms of transforming protocols, security protocols, and so on. Because then we need to follow the certain guidelines. Because finally, your machine is about to connect with the world. So here, from this point onwards, the machine is going to be open for others. Here, point number 1 to 5, it is integral part of your company, integral part of your software. And out of that also, first 3 are physical hardware related things. Then you are having a sensors and microcontrollers. Still, it is a kind of transition phase, hardware plus software, because you are having a hardware in terms of sensor, but finally it is going to work through the some kind of software which is embedded with the microcontrollers. And from the 6 point onwards, it will be open to the cloud, right? And then you decide how you are going to represent that information, what you are going to collect, right? So in that sense, we may have a different representation platform. It may be Android, it may be dashboard, it may be iOS, it may be any other uh, operating system for the device on which you are going to represent your information, what is available into the server. And then you are going to decide the representation method on this particular platform. It may be in the form of statement, it may be in the form of numbers, it may be in the form industrial Internet of Things hardwares. There are certain transition or transitional devices, and then there is a this device will be open for others to for the visualization, right? So that's what overall scenario of the industrial Internet of Things. Then actually how you are going to deal with that further, right? That will be the part of the next system. But industrial Internet of Things somewhere, although there are a lot of confusion available uh, in the pure definition of IoT, but we, as far as this course is concerned, we are going to restrict our understanding up to that point, that industrial Internet of Things will be uh, going towards the representation of the data, and then you are going to store that information, and then this information may be utilized for any other purpose. But here actually, if you will disintegrate this term, so there will be an industrial system, and it is covered over here. Things, it means the industrial system and their particular things in terms of parameter. And then actually we are going to connect all this with the help of internet. And then we are streaming that information to the any particular server, whether it is your own client-based server, cloud-based server, by following the protocols called MQTT and AMQP, Node, JSON node, whatever. Right? There are multiple protocols that we are supposed to follow. We'll go into the detail of an individual aspect, and then we are going to represent the information either onto the dashboard or Android. And during the progression of this course, we will also have a demonstration on that. So we will also select one of the open platform for this monitoring part, and embed your system onto the Android and particular dashboard. So we are going to have that kind of hands-on session. And everyone, I think nearly 30 students are into this course. That's what I have seen earlier. So maybe we'll divide you into the certain groups. If it is not possible, I'm also okay with the individual task. So I will give you the list by the next lecture, maybe into the Tuesday session or like that. or meanwhile, I will also share the list onto our WhatsApp group, so that you will have to procure, and we will guide you through that how the physical systems are going to happen. Maybe we'll start with the typical monitoring of the environmental condition open platform. So you are not supposed to worry about the API generation and all these things. That will be automatically generated. So few of the my associates will also guide you in that sense. And so maybe next lecture Tuesday will be purely based onto the theoretical aspect, and then actually slowly we'll move towards the purely practical aspect of the cyber physical system. As I told you into the previous session also, there are so many presentations, so many stuffs are available in the direction of cyber physical system, but our objective is not to impart the knowledge, but our especially my own objective is to impart the skill associated with the cyber physical system. So as a part of that, an individual need to develop their own small system by the end of this course. Then and then it will actually have a confidence in that way, because so many better actually facilitator than me, their videos are available onto the YouTube. So I'm not talking about anything new over here, which is uh, already available into the so many reference books, so many videos and so many stuff. But unless we are not going to have a hands-on session onto the cyber physical system, it doesn't have any purpose, right? So this is the overview of the IIoT. Now actually we are going to go into the typical overview of the cyber physical system. Although marginal difference into the entire system. And what is my perception about these two, IIoT and cyber physical system, that I will tell you. In general, if you will also Google the IIoT and cyber physical system difference, you will find that the IIoT is limited up to the monitoring part. It means what is going on into my system, I can monitor. But if you want to have a feedback system, it means the controlling of the equipment from anywhere. That is the domain of cyber physical system. So in cyber physical system, we are not only monitoring the system, but we are also identifying the optimized parameter, and then again we are going to feed that optimized parameter into the machine itself. So cyber physical system, it is mainly a closed loop system, while the IIoT is a kind of open loop system when just you can monitor the things what is going on into them. So it is basically limited up to process monitoring, and cyber physical system not only monitoring but about the controlling of the machine itself. So for this actually, as far as the context of this course, we will take these things into our memory, that IIoT will be limited up to process monitoring, and cyber physical system will give you the idea about the closed loop system. So if I'm going to talk about that just same way into the overview, I'm going to identify the physical system. So suppose I have already identified my own physical system in terms of mechanical. So there are various physical systems like say casting, forging machine or machining, etc. So suppose I will pick casting process or forging, depends upon individual's interest. Then actually again onto the step number 1 and 2, we are going to identify the parameters, we are going to identify the sensors, we are going to place the microcontroller, right? And we are going to develop the embedded system for entire process or entire machine. So basically we are going to collect the data related to process parameters through sensors plus embedded system as a second step. And then we are going to stream the collected data to the cyber system for further computational purpose. Again, the cyber system is nothing but one kind of server. It may be client-based server or it may be cloud-based server. So here actually, the first 3 steps are more or less creating the analogy of the IIoT system, what we have discussed into the sixth, up to the sixth part of the IIoT. Over. So then actually how we are going to represent the data. So fourth system, we are here going to discuss about the development of digital twin for mapping the physical system with the cyber system. So it is nothing but one way of representing the data from the server. It may be with the help of digital twin, it may be with the help of augmented reality, it may be with the help of Android dashboard, or it may be onto the iOS also. So here up to this point, it is IoT, IIoT, industrial IoT, up to fourth system. So earlier, all 7 systems IIoT are covered from first 4 steps into the cyber physical system. So from here, actually, the spectrum of the IIoT has been extended to be considered as a cyber physical system. So here actually we are going to process the past data and the real-time data through the data analytics. So here, as the Mr. Shunil was mentioning, we are going to do the something about the big data analytics, and now we are going to involve our outcome. It means whatever my expected outcome, whether it is going to be a productivity, whether it is going to be a efficiency, or whether it is going to be any kind of collection and the representation of the data. So here I am going to, once I am having a data, then it is going to be stored into my server. So I'm going to process the past data, whatever the data is actually streaming currently onto the system. So I'm going to have a analytics of the real time data. Once I will process it, I will be in position to find out the best optimized solution, whether it is in terms of the quality, whether it is in terms of productivity, whether it is in terms of overall equipment efficiency. Generally, as a MNC or large scale manufacturer, we are interested into that overall equipment efficiency, OE we are counting, and to achieve the best outcome, we are going to identify the best optimized solution. So here there are multiple approach. How we are going to process the past data with the help of big data analytics, and to the big data analytics, we may have a machine learning, we may have a genetic algorithm, we may have a simulating annealing, we may have a different optimization techniques. It may be classification in regression tree, it may be a classification problem, it may be a regression problem. That is all computational related stuff, what we are supposed to discuss, right? And then actually, once we are having a optimal solution, we are going to again feed that optimized solution into the physical system itself. So we are going to develop a system that will feed the information back to physical system. So then actually into the next cycle, it will have a process parameters which are optimized to achieve the better outcome. And then actually the entire system is going to be considered as a feedback system. So we are also intent to develop the one kind of system that will actually feed the optimized information again back to the physical system, so that into the next cycle of working, quality or a productivity can be improved. Right? So this is all about the cyber physical system. So there are two main aspects. One that is industrial Internet of Things. Another one is cyber physical system. Most of us actually are confused while actually we are trying to discuss about the IIoT and cyber physical system. But as far as my perception is concerned, we do have a slight or a marginal difference between these two. As IIoT will help you to monitor the system, while the cyber physical system will have a system that will actually again take the optimized solution into the system and run the entire cycle in an optimized way. So that is my perception about the cyber physical system and IIoT. IIoT is mainly limited to the monitoring, and cyber physical system is closely related to the feedback system. It means not only monitoring, but also finding out the most optimized solution to take it further level, right? So any confusion, any doubt, anything that you would like to know? So if I'm going to disintegrate my entire course of the cyber physical system, we are also going to go into the 7 system as we have defined into the curriculum itself, right? So first, I will give you the overview about my own experience about the cyber physical system in terms of casting process. It means I will take the casting process as a case study, and I will explain you, I will try to explain you that for the physical system associated with the casting, how we have identified the parameter, how we develop the embedded system, how we are actually streaming the collected data, and we also develop the digital twin, then we also process the data, we have identified the optimized solution, and again we are feeding the optimized solution into the system, and then the entire system is going to work. So I'm going to into the next few lectures, uh, I will try to explain you the cyber physical system in the context of casting. Then actually your work will start as a part of your assignment, right? Everyone need to go through the one course project in which you will have to select your own physical system and follow all this step. So for this step, actually, we'll be having one hands-on session on each system, right? Everywhere we are having a hands-on session on that. And for that, actually, you need to procure certain things. So I will give you a list of the items that you are supposed to procure. It may be into the group assignment, it may be an individual assignment. That will be your choice. You can respond me onto that part, onto that point, whether you want to go with the group assignment or whether you want to go an individual. Because at that point, the real learning will come, right? Because uh, I will discuss about my perception, right? There is no doubt about that, and I will discuss you the case study related to casting. Casting in terms of research lab, what we have carried out at the Marwadi University, and then I will also discuss the casting in the context of industrial application. So for that, actually, I will discuss with you one industrial case study, that how their all the equipments we have connected through the internet. We have prepared the digital twin for that. We have developed an embedded system for them, and then how the systems are going to work for industry. Right. So I will. I will discuss in the both the context, right? So, any confusion, any doubt in this point, right? Or otherwise, I will just run through the one small video how the typical cyber system of the Century Tire at the Thailand factory, which is all we are having multiple videos. Just I'm going to run through this video itself, and then actually we'll discuss the other videos onto the next session. Because we are running out of the time on the today's session. So just I will go through this very small video. You can see that how the cyber system, physical systems at a particular factory is working. You can also So, any thoughts from your point? Because as far as the discussion is concerned, we are at the end of the session. So, if you want to say anything, right? Any confusion, any doubt so far? What we have discussed, what we are trying to put as our thought, as far as the IIoT is concerned, or a cyber physical system is concerned, then actually we'll stick to that 7 steps of the cyber physical system, what I have just shown over here, and we are going to explore it, right, one by one. So these are the what you can say overview, what we are trying to discuss into the entire course. So we'll again go into the individual step and further explore it. For example, physical systems, as I told you, for the understanding wise, we'll take a casting as a case study. Then we'll identify the parameters associated with the casting system. We are going to identify the sensor. We are going to identify the typical microcontroller for that. Then we'll also learn that how to stream the data to the server. We'll also try to learn that how to develop the digital twin out of it. Then we'll learn how to process the data with the help of some data analytics techniques. And we are trying to predict the information with the help of artificial neural network. I will also give you the cloud-based application for that. Then we'll also discuss how to develop the best optimized solution. Then we'll try to again fed that optimized solution into the system and see how the things will work, right? So this is the overall. First, I will try to explain from my point of view, and then you are going to select your own physical system, and we'll try to do the hands-on session. So, as a part of into the next lecture by Tuesday, you should think of your own physical system that you are going to consider for your analysis. Suppose I'm going to have a casting system, so maybe you can select any one of the system where you belong. It means where you are working or where you are willing to work. So select that particular physical system, and we'll try to do that. Right? So we'll also have a hands-on session on that. I think it is okay with everyone, right? Anything? Any confusion what we are trying to discuss? So is it okay, the flow of the system, what we are trying to achieve? It means it depends on to the interactive way, right? How you are going to see and how I'm going to work in that sense. So you are also going to select your own physical system, right? So anyone, any confusion in that part? So by the Tuesday, I would suggest you think of your own physical system. Although from the Tuesday onwards, you are not supposed to apply this kind of fundamental to your own cyber physical system. But I would suggest you to go through it. It means mentally you need to be prepared about your own cyber physical system, right? So any confusion into that? Any discussion, anything that you would like to ask? Otherwise, I think we'll end the session over here. Anything from your side? Yes, anyone?
Is it okay, sir? You explain it very crystal clearly.
Oh, thank you.
Okay, sir.
So yeah, we are going to select our own cyber physical system for which we are going to analyze, right? Right. So by this, I think we are ending the session. Thank you all for having patience in listening. Thank you all. and enjoy the Sunday. Right? Thank you. Bye.